what we do now is something called a community moment. So this is an opportunity for somebody from the community to come up in 10 minutes or less and tell us about just about anything. They could tell us about a hobby that they have. Maybe they're going to tell us about their journey to Oasis. Today, we are excited to welcome back a veteran community moment and main talk presenter. Houston Oasis, please welcome Eric Schmitt.
Thank you. So today, the title is The Fallacy of Evolutionary Primacy. That's actually a topic I've already spoken to you on, where we've discussed how there's this notion that man's the epitome of evolution. Everything, every species is specialized to its own niche. Humans did not inherit the best solution for everything. And so today I want to build upon that by entertaining the question of modifying the content of the human genome. This has been very much in the news of late due to the announcement by Dr. He of the birth of twins who were genetically modified. And in a prior talk, I told you about a case of gene modification of a boy who had his skin detaching due to a gene mutation. And they took some skin cells and through the application of a virus introduced the necessary gene and saved that kid's life. And so I thought I would take a few moments to point out why the difference in response. Why did people jeer Dr. He's announcement of the birth of these girls who had been genetically modified and cheer the announcement of saving this boy's life who had the problem with his skin falling off? Well, for one, curing the boy was consistent with medical principle of restorative therapy. His broken gene was causing great morbidity and threatening his life. The functional copy that went in restored normal gene function. Now, in the case of the twin girls, the goal wasn't to restore a non-functional gene, it was to break a functional gene. So the particular gene that was targeted in the girls serves as a receptor to the HIV virus. It's one of the routes in which HIV can enter and infect an individual. And so the girl's father has HIV infection. And so the notion was break this gene and you'll reduce the chance that they will contract HIV from their father. So is that medically restorative? It's kind of got some medical benefit in it. But you actually have to break both copies of the gene in order to get that function. That happened for only one of the twins. So the other twin who had only one copy of her gene broken is still susceptible to the infection. But also, you know, there are other less intrusive ways to reduce the risk for AIDS transmission. In fact, even without targeting these genes, there's not much risk for these girls to pick up HIV. So that was one of the failures in that procedure, was really balancing the risk versus the benefit. Now, sure, if the girls had contracted AIDS, if you avoided them contracting AIDS, HIV, then that's a great benefit to that individual. But breaking this gene does not eliminate completely the risk for transmission of HIV. There are other routes for the virus to get into a cell. So it didn't really achieve its goal there, and there are far less intrusive ways of achieving the goal of reducing transmission risk. Secondly, the targeted gene has a function. So that gene that was destroyed to remove the risk for HIV infection actually does something. You have it for a reason. And the reason appears to be it's functional in differentiation and immune response, and seems to be important in developing immune memory. So, yeah, there are people who are naturally born who have 2 broken copies of this gene. They don't seem to be suffering greatly, but, you know, they may be at some disadvantage. And we really don't understand that very well. So it was premature to make the decision that this person would be better off without functional copies of this gene. The bigger concern, though, is for off-target genetic modifications. So he went in to damage this particular receptor for HIV. And the concern is that in doing so, it could have produced damage at other parts of the genome. And if you destroy a gene that you need somewhere else, you can cause very serious problems. Or if it goes in the wrong place and causes genes to be expressed at the wrong levels or the wrong time, perhaps you're going to promote cancer. So that was one of the big concerns. The other was really what was targeted. So really the biggest difference between the boy who was cured of his disease where his skin was falling off and these girls who were treated to prevent HIV infection was that in the boy, they took off some skin cells, and they found the stem cells for the skin cells in there, and they replaced the gene in there. That affects his body. It does not affect the next generation. But for these girls, there's a very real chance that the changes that were made could be passed to their children and on down. And the reason for that is the cells that make up egg, that produce the egg and the sperm, those are called germ cells, get set aside during embryonic development very early, at about a week. And so when you're working on a very early embryo that's only a few cells, the chance that those cells are going to contribute to that germ line and make it to the next generation is pretty high. And any changes that you made that end up in that germline are in that germline forever. So if you made a mistake, if you acted on incomplete information, that mistake's going to be perpetuated to their children, their grandchildren, perhaps to a descendant that you share a relationship to. So you need to consider what the risk is from modifying the germline. And really, there are criteria that need to be met. There has to be a clear benefit. There has to be high confidence that only the intended change was made. You have to have high confidence that the change that you made is stable, that it's not going to jump somewhere else or reverse itself. And reversing itself is actually an interesting topic because perhaps what we need to do is build these in a way that if things go wrong, we have the ability to reverse them. The benefits should outweigh the risks, and clearly that wasn't the case in the situation for these twin girls. Scientific concerns, there should be a scientific consensus that the procedure is logical and likely to provide benefit, and there needs to be an ethical consensus that it's the right thing to do. And you can get down that slippery slope pretty quickly. I'm going to walk you down it a little bit, just so you can see. So, for example, would it be permissible to correct a mutation in an individual that has a mutation that puts them at risk for cancer? Let's say breast cancer. They don't want their children to have it. Is it morally defensible to get in there into the embryo that was produced by IVF and try to fix that gene before putting the embryo into the woman? You may say, yeah, of course. but it depends on relative risks. It's always going to be, at least presently, it's easier to identify amongst the embryos that were produced an embryo that did not inherit that gene, the mutation, and implant that embryo. And don't implant embryos that did inherit the mutation. No need to do the gene fix. Okay. Now, there are some circumstances where one really gets forced into you don't have an alternative. I posed to you a couple questions. If somebody had a genetic condition that produced short stature, would it be appropriate to put a gene in that increased their stature? And you might say, yeah, that's restorative medicine. How about if it's somebody who doesn't have a genetic predisposition to short stature and they just want to be tall and athletic? Does that give you some pause? And then finally, what I would like to say is that as we get in, I want to return to the topic of evolutionary primacy. There are good solutions that other organisms have come up with for things. We could put those into our genome. And some of the things you might think of are things that increase our lifespan. Most of them that we're going to increase health are going to increase lifespan. You got to be concerned about what that does, what the consequences for that may be. If everybody lives longer, you're going to have to adjust reproduction rates. What's that do to social evolution if everybody's living longer? Let's say the founding fathers were still around. Would society have benefited from an increased? Would we benefit from the acquired knowledge of those individuals, or would we be stuck with unchanged ideologies? So some things to think about. We're headed that way for gene therapy, germline gene therapy at some point. So introducing the topic. Thank you.